Let's start them. These routers are not as configured actually. Just enabling the interfaces. Just ensure we are able to reach the other end of the router. Okay, we are able to reach R1. We'll use the interfaces fast Ethernet 0/0 of both the routers that are connected to each other. And we will advertise our loopback 1 network on EIGRP and see how it is learned and how the table looks like. So we are forming the we'll use router EIGRP 100. Is the 100 is the AS number we are using. That's the first command. Next command would be the network and all the networks all the interfaces on which we have to advertise EIGRP. We'll be running EIGRP only on fast Ethernet 0/0/0. So use that and use the wildcard mask. Once we put this, the EIGRP neighbor should come out. Yeah. So we saw the new EIGRP neighbor sheet. Here. We show the EIGRP neighbor. We can see the neighbor found 12.1.1.1 is R1's address. And here we should see the neighbor 12.1.1.2. 1.2. We will just see how the packet looks like. How the EIGRP packets would look like. So you can see this in EIGRP hello packet. So as earlier I said, this is the packet from router 1, 12.1.1.1. The destination address is 224.0.0.10. It's a multicast address what is used by EIGRP. So what it has is the version of the EIGRP it is running and the address family it is using. So not much packets. Once the neighbor, it will just break the neighbor and see how the neighborship packets are exchanged. So the neighbor went down and the neighbor came up. So we see here the update packets. Let me stop the capture. So here it was all, you can see the destination address was to the multicast address. But once dot 1 received an multicast packet from dot 2, it started sending a unicast update. See, now the destination address is 12.1.1.2, and you can see the flags is set to init, whatever I said, whatever we saw in the slide that time. And there should be a reply packet, acknowledgement packet for this update packet. That will be from 12.1.1.1 to 1. Actually, 12.1.1.2 also sent an update packet. It's not an acknowledgement packet, but indeed here we got an acknowledgement packet from dot 1 for this update packet. For that, it has to start exchange the updates, but we have not advertised any other networks, so there is no further updates that has happened. So we'll continue to capture. Okay, it's doing. We'll advertise our loopback on router 2. Currently router 2's routing table is now having only connected and local routes. We call C as connected routes and L as local one. Local is whatever configured on the local router. So if there is an EIGRP route, it should be with the letter D. We are not able to see anything with the D. You can also filter it with the show IP route EIGRP. That would show whatever routes with specific to EIGRP. We do not have anything as of now. So now we advertised the loopback one. How to see if we have really advertised EIGRP on the interfaces? You have to give show IP EIGRP interfaces. That command shows on what all interfaces we are running EIGRP. Now we are running on fast Ethernet 0/0 and loopback one. These are the two interfaces on which we are running EIGRP. And this is show IP route EIGRP. Now we see one route from the neighbor 12.1.1.1 27 seconds back, and the outgoing interface from our end would be fast Ethernet 0/0. We shall also try to understand show IP EIGRP neighbor command. Here we see multiple fields. H, I think it's called, I'm not sure exactly what it's called. Actually, if we have multiple neighbors, the sequence starts from 0, 1, 2, 3. It's a serial number kind of thing actually, but I'm not sure of the exact reason why they called it as H. And the address is the neighbor address. Neighbor address is 12.1.1.1 is the R1's address, and the interface through which we are learning this neighbor is through fast Ethernet 0/0. And the whole time actually, let me share you this thing also. Show IP EIGRP interface detail. Yeah, by default we call hello interval is 5 and the hold time is 15, which means every 5 seconds a hello packet is sent from one neighbor to another neighbor, and if there is no hello packet received within 5 seconds, it doesn't do anything. It will wait till 15 seconds. If there is no hello packet that is sent till 15 seconds, then the EIGRP reconvergence will start happening, saying that this neighbor is not reachable to start the reconvergence process. It will reset the neighbor. Hello interval is 5 and the hold interval is 15. Whatever you are seeing, the hold is here 11 seconds. Which means an update was sent 4 seconds back. So this will reset every 15 seconds. An update is sent. If an hello is received, it will count. It will reset this to 15 again. It will start counting 15, 14, 13, 12. If an update hello packet is received, again it will reset the counter from 15, 14, 13, 12 based on the hold time whatever we have configured here. And this gives the uptime how long the particular neighbor is up. It is up since 3 minutes 41 seconds. And SRTT is the smooth round trip time. It is say a hello is a packet is sent and how quickly an acknowledgement is sent back. So it is like 37 milliseconds is the, we can term it as a latency between the two devices actually. So a packet is sent, how quickly a packet is replied to that. And RTO is the retransmission timeout. So the router will the router, as I said, it uses RTP to send the packets repeatedly. The router waits for so much of time to send another packet actually to retransmit the same packet. That is called retransmission. And the queue count, if the network is fully converged, if all the routers are aware of all the prefixes, whatever R1 is aware everything it has sent to R2, and whatever R2 is aware it has sent everything to R1, this queue count should be 0. If something R2 is not able to send updates to R1, that will be stuck in this queue. So if it's something greater than 0, which means there is some problem between the neighbor. This router is not able to send all updates to another neighbor. And sequence number is since there are multiple updates sent, it is it tracks using the sequence number to know the latest update. Say it receives some update or something other than the router retransmitted. But it checks the sequence number. If it's the same sequence number, the router would not do any changes on its on the update that is received. If it's something different, then it has to update its routing table. That is what it is. So let me see whatever we advertised, one dot network. This was the first packet. Stop the capture. It is. Okay, it's update to a specific neighbor. I'm not sure whether we captured that or not. As an acknowledgement, there should be an update packet from 12.1.1.1. Okay. Anyways, let me stop this capture. I thought of showing you that particular packet. Not sure if I missed it. Every cast packet. This has a flag in it, so this was the first packet. the regular hellos. Yes, that's how it works actually. There will be a reply packet, sorry, update packet about the 1.1.1 information. So we saw the classic mode of configuration, how to enable router EIGRP globally and how to enable on the particular interfaces. Just understanding some commands, show IP EIGRP interfaces would give the information as to on what all interfaces we are running EIGRP on, and we are seeing on Wireshark. We can see on debug IP EIGRP packet also that hellos would be sent every 5 seconds and acknowledgements will be sent